You look into the sky and see the beautiful sun and the stars. Were you aware that you can learn more about the composition of the sun and the stars by using an instrument called a spectroscope? Yes, it is most certainly possible. In fact, this instrument can be used to determine the composition of other items, such as a planet or even a light bulb. Spectroscopes are instruments that allow scientists to determine the chemical makeup of a visible source of light. The spectroscope separates the different colors of light so that scientists can discover the composition of an object. Now, to really understand how this instrument works, we need to review basic concepts of white light and its relation to color. If we focus on light in general, we will see that it consists of distinct wavelengths. A wavelength is the distance between two crests or troughs. Each color in light corresponds to a wavelength. Our friend, white light, just so happens to contain all of the colors, or the entire spectrum of visible light. Examples of white light include our pals, the sun and the stars. What happens when you take a spectroscope and place it in the presence of white light? Great question. When the spectroscope comes into contact with white light, it splits or diffracts the light into all of its colors. This causes each of the colored beams to point in a different direction, allowing you to view each color as a single, narrow band. This band is often viewed as a dark line called the absorption line. Recall that a spectroscope allows us to determine the atomic makeup of visible light sources. When an atom gets excited or happy, it emits light. This emission of light corresponds to a signature spectrum we call an atomic spectrum, which is a spectrum made from a group of colored lines that are formed when atoms become excited and emit light. By comparing this signature spectrum to the absorption lines viewed by a spectroscope, we can learn about the chemical makeup of an object. Let's say we take the sun and decide to study the composition of it by using a spectroscope. We determine the spectrum of the sun as shown in the illustration. The dark lines or absorption lines we see from the spectroscope can be compared to known atomic spectrums. From this comparison, we discover that the sun contains the atoms hydrogen, sodium, and magnesium. Although an example, you can see that the spectroscope can be quite useful when the need arises to learn more about the chemical makeup of material, such as that of the sun. What are the different ways a scientist can use the spectroscope to learn about the composition of light source materials? Well, they can learn by measuring one or all of the following: the actual color of light that is distinctly observed, the color of light that is reflected, and/or the color of light that is absorbed. Now that we have defined a spectroscope and understand its importance in science, let's take a look at the different parts used to make this instrument. There are different parts of the spectroscope, all of which are necessary for the instrument to function properly. Here's an illustration highlighting the main parts of a spectroscope. There are three main parts to a spectroscope: the slit, the diffraction grating, and the viewing port. The slit is the first part of a spectroscope. This part determines how much light enters the spectroscope. The second component of a spectroscope is the diffraction grating. This determines both the range of wavelengths from light as well as the optimal resolution, or how sharp the image will be. If too much light enters your spectroscope over a wide range of angles, it may be too difficult to determine the wavelength. Also, the ability to view a single color band might not occur. The last part of the spectroscope is the viewing port. This is the opening to which you are able to view the light that is split or diffracted. It may be of no surprise, given our earlier example regarding the sun, that the spectroscope is highly useful in astronomy. You may encounter a spectroscope partnered to a telescope when the desire emerges to learn more about the atoms present in stars, planets, or even interstellar space. Chemists also enjoy working with spectroscopes when the need to determine what atoms are present in a material is required. Just by heating a material, they can understand its chemical composition by examining the flame with a spectroscope. In fact, this method was used to discover some elements we see on our periodic table today. On a smaller scale, did you know this instrument is also used to identify unknown gemstones? Each stone has its own characteristic absorption spectrum. When you shine light through a stone, you can analyze the light emitted using a spectroscope. This analysis allows you to identify what the stone is by comparing its spectrum to a known signature spectrum. Spectroscopes are instruments that use the properties of wavelength and light to investigate the composition of substances. Specifically, the atomic spectrum is used to learn about the composition of an object. White light is the type of light viewed by a spectroscope. Different sources of white light include stars and the sun. There are three main parts of a spectroscope: a slit, a diffraction grating, and a viewing port. The spectroscope is used by astronomers to study objects, such as the galaxy of stars. Another use includes the identification of unknown gemstones.